All right, good morning, everyone. I'm glad to be back with you. It's not what I would prefer. I would prefer to be in the classroom with you in front of me so that we could see each other and talk face to face. I really do miss you guys, but this is going to have to be the substitute for being together for a while anyway. So this is Physics 30. I'm calling this the rest of the story. What I'm going to be doing today is going through what the structure is going to look like for the next 2.5 to 3 months, and then we're also going to be doing a little bit of review of something that we learned in Physics 30 before this whole fiasco took off. So this is part one of Physics 30, the rest of the story. I'm only going to be providing you with the resources for about 3-week periods at a time. So this covers everything from April 1st to April 21st, and when you count the number of official kind of lessons, there's only 8 lessons there. And there are around 15 school days in that period, which means that you're not learning new material every day, but you are still expected to do something every day, and we'll get to the structure of that in a little while. I've printed up the schedule on the title page of this document for you so that you know when we're learning what we're learning. I think because you're not in contact with the teachers, it's very important for you to try to keep track of the pace of things. At the beginning of every part of the remainder of this course, I'm going to be providing you with due dates and dates regarding assignments. You're going to have 2 assignments which are going to be given to you. One will be given to you today, and it will be due to be turned back to me next Tuesday. And assignment number 2 in this 3-week period is made available to you on April 8th, and it's due April 13th. So on those days where I do not have a video lesson, and those days are April 3rd, 7, 9, 13, 15, 17, and 21. On those days, I will be logged into a Google Hangout, and there's the address. I'm going to invite everybody to that address, which is going to give you permission to go to that chat room. And when you go in there, if you have a webcam on your computer, I will be able to see your face. You'll be able to see my face, except that I'm probably going to be in what we call presentation mode, and that means you won't be looking at me, you'll be looking at the smartboard that I'm writing on. You can think of these days as being the opportunity for you to ask questions. Normally at the beginning of every class when we were in school, I would always start by saying, okay, let's get our homework out. Does anybody have any questions you'd like me to go over? Well, this is the opportunity for you to do that. And I am going to be available during the time period that our class was taught in, from 8:50 to 10:10. There are other times of the day where I will be in a different Google Hangout room or Google chat room for other groups of students, but this is time reserved exclusively for Physics 30 students. If you do need to meet with me or discuss things at a different time, send me an email, and I'm sure that we can figure something out. This is just a reminder that there is a shared folder for all of your resources. If you are missing something, if you need a formula sheet or you've lost a handout, you'll be able to find it in this shared folder. All students are expected to enter their Google Classroom every weekday to obtain the link to a daily lesson or any other assigned activities and instructions. The reason for this is, well, there's a number of reasons. One of them is, I want you to keep track of what's going on. The other reason is that things can change pretty rapidly, and we've seen that over the course of the past 3 weeks or so. So even though I have a schedule, a pre-planned schedule for this part of the rest of the course, that could change. And you need to check in every day and find out what's going on. There will be a post every day telling you where you should be at and what you should be working on. Now, many of you have already asked about this. What about your mark? Well, Alberta Learning has been giving us conflicting messages. One of the messages is, basically, if you are currently passing a course you're enrolled in, you will pass the course. The other message is that schools and teachers are responsible for developing the method of evaluation. So we are going to go with, in the math department, awarding a percentage mark. It may very well be at the end of the semester that students are simply awarded a pass or a fail, but I don't want June to come around and Alberta Learning say to me, oh, you need a percentage mark. And for the past 3 months, I haven't been marking anything. I've just been kind of judging you based on pass and fail. So we're going to be looking at the following scheme. Whatever mark you had when this whole thing started, that counts as 40% towards your school awarded mark. Your weekly assignments, and we'll talk about them a little bit later, you'll have one assignment roughly every week that's turned into me, are worth a total of 40%, and your final assignment will be worth 20% in total. There's no diploma exam. The diploma exams have been canceled. So we're going to get started today, and we're going to review projectile motion. I'm calling this projectile motion the second coming. And all we're going to do is work through one example together. And then at the end of this, I'm going to direct you to where you can download assignment number 1, which is based on this example, so that you can get to work on it. This is very familiar to us. What we have are 2 parallel plates. There's a voltage between the plates of 1200 volts. You're told that in the question. And you're given all of these distances which are on the diagram. The lines are pretty faint on my smartboard, so I'm not sure if they're faint on the handout or not, but I'm just going to highlight them. We've got a dotted line here. We have a dotted line here and here. So you're given those distances and you're given the voltage between the plates, and that's essentially it. Now I'll remind you that when you're doing projectile motion problems, the standard approach must be to treat the horizontal and the vertical motion separately. So the horizontal motion is motion that occurs horizontally, obviously, but the important aspect of the horizontal motion is that it's uniform motion. And the reason for that is really straightforward. The particles in this beam are traveling left to right, that's their velocity, but the force acting on them, which happens to be an electric force, is acting towards the bottom of the page. And since the electric force is acting perpendicular to the direction they're moving, that electric force cannot speed up that horizontal velocity, and it cannot slow down or decrease that horizontal velocity. So what's going on here in the horizontal column is we have uniform motion. On the other hand, when you look at what's happening vertically we have non-uniform motion or linear acceleration. So what we have are all of these formulas in that box which are dealing with vertical motion. We have an electric field that's vertical. We have a force that's vertical. We have an acceleration, a displacement. All of these things are vertical, whereas over on the other side, what we are dealing with over here is uniform motion, and that means that there's only one formula you can worry about or need to worry about, which is speed equals distance over time. We can go ahead and put in the information that we know. Now, there's really not a lot that we know that's actually given to you in the question, but you are told that the potential difference is 1200 volts. We also have some distances. Now here's where things will get a little bit different. In the past, normally when we started to look at, say, the distance in the vertical column, you would just worry about how far apart the plates were. But when you look carefully at this diagram, the vertical displacement of the protons as they move in the region between the plates is not 8.25 centimeters. The actual vertical displacement, the distance that they move, is whatever this distance is. And we can find that distance by taking 8.25 and subtracting 1.9. This is the vertical displacement of the particles. So we're going to have to start with taking 8.25 and subtracting 1.9. I think it's 6.25 or 6.35 centimeters, but I'm just going to double check. 8.25 minus 1.9 gives me 6.35 centimeters. So in meters, that would be 0.0635 meters. The other thing we can figure out is the horizontal displacement. Well, I don't think we really need to figure out. It's given right in the question. You can see that they travel horizontally, these little particles, 21.2 centimeters. So that means that we can put 0.212 meters for the horizontal displacement. Now, what you're asked to determine is the velocity that these particles have when they enter the region between the two plates. So what's missing is the time. If we knew the time, we could find that speed. But you need to remember that these two times are the same. I mean, clearly it's only one particle or one set of particles that moves in that curve. It isn't that you have some particles moving to the right and you have different particles moving down. They're moving to the right and down at the same time. Now the problem is, how can you determine that time when you only have the displacement and the initial velocity? The answer is you need to find another kinematic descriptor, like the acceleration. Well, if we knew the force, we could find the acceleration. If we knew the field, we could find the force, and we can calculate the field by using the voltage over the distance between the plates. So here's the trail that we have to follow. You have to calculate the electric field so that you can calculate the force, so that you could find the acceleration, so that you can find the time, so that you can find the speed. And that's what we're going to do. So to begin with, I'm going to calculate, well, you know what, in all fairness, let me write this out. We need to calculate the electric field by taking the voltage over the distance between the plates. It's been a while since we've done this. Then what you're going to have to do is use that to find the electric force. Then what you're going to do is use that electric force to determine the acceleration. Then you're going to take your kinematics formula of d equals a half at squared. I guess double the distance and divide by the acceleration and then take the square root, and that will give you the time. Then when you know the time, you can take the distance over the time to get the speed. I should have mentioned this. This is new to all of us, but clearly you're watching this on a video, so you have the luxury of, if you feel I'm going too fast or you need to write something down, pause the video. If you ever come up with a question in your head that you need an answer to, pause the video and write the question down, because if you don't do that, you're liable to forget that you actually had a question. Or you might remember that you had a question, but you might not remember it. So this is what we're going to do. We're going to calculate the electric field by taking the voltage over the distance between the plates. Now, very careful in what I said there. This D in the formula, this D right here is the 8.5 centimeters. I want to just go back and see if it was 8.5. I can't remember. 8.25. That distance is actually 8.25 centimeters, which is 0.0825 meters. When you get down over here, this distance is not the whole distance of 8.25. It's that, I think it was 6.35. We'll go back and check it in a second. But let's go ahead and calculate the electric field. I'm going to take the 1200 volts and divide by the distance between the plates. This gives me an electric field of 1454. That's not right. 1200 divided by 0.0825 gives me an electric field strength of roughly 14,500. volts per meter. We're going to take that electric field and pop it into the force formula. So if I multiply that electric field by the charge of a proton, which is the elementary charge, this gives me a force of 2.33 multiplied by 10 to the negative 15. And that, of course, is newtons. If I take that electric force and I divide by the mass to get the acceleration, I'm allowed to take that electric force and divide by the mass to get the acceleration because the electric force is the net force. The electric force is the net force because the electric force is the only force. So I'm going to divide by the mass of a proton. I remember what it is, but it's been a few weeks, so you might all have to look it up. The mass of a proton is 1.67 multiplied by 10 to the negative 27 kilograms. What I get is an acceleration of 1.39 multiplied by 10 to the 12 meters per second squared. Now remember, this vertical distance when you're dealing with the next step, this vertical distance is the distance that the particles actually travel, which we figured was 0.035 meters. Okay, so I need to take 2 multiplied by that 0.0635. Can't believe I forgot that in the span of 10 seconds, but I'm going to go back and check. Then we need to divide by the acceleration, which is the number that's on my calculator. Then we need to take the square root of the answer. And that's giving me a time of 3.02 times 10 to the negative 7. .02 multiplied by 10 to the negative 7, and that would be seconds. Then we're going to take that distance. I believe that distance was 0.212 meters. Yes? So we're going to take that distance of 0.212 and divide by the time, which gives me 7.0 multiplied by 10 to the 5. I'm just wondering about the significant figures here. We're going to go with 2 significant figures because of the 1.2 kilovolts. So our final answer works out to 7.0 multiplied by 10 to the, I want to say 5 meters per second. So hopefully that gets your intellectual juices flowing in terms of solving a little bit of physics. It's been a while. It's been close to 3 weeks since we've done any of this. This is our final answer. So now you're going to have an assignment, and this assignment is due April 7th. I want to talk very briefly here about the expectations for assignments. You're going to find the assignments in a shared folder that I'll show you in a second. Responses on the assignments must be handwritten. I will not accept typed out solutions to physics problems. And they must be easy to follow. All work must be shown. Now you have 2 choices. You can either print out the assignment and do your work right on that sheet of paper, or you don't have to print it out necessarily, although you will for this first assignment. But for all other assignments, you don't necessarily have to print it out. You could just do your solution on a sheet of paper, because in the end, what you're going to do is you're simply going to take a picture of your work and email it to me so that I can mark it. Now, I'll show you where the assignments are. When you go into your shared folder, now your folder will look considerably different than my folder, but you go into your shared Physics 30 folder that I've shared with you, you'll see that one of the subfolders is Physics 30 assignments, and inside of that is assignment number 1 as a folder. Inside of that, you will find an assignment with your name on it. So I'm just going to pull one up here. We'll take a look at Dan's. It's got his name on it. It's a very similar question to the one we did, except you will notice, everybody, that on this particular question you're not given any of the distances. I'll get to that in a second. But the important thing I want to draw your attention to is all of this. And you're familiar with this, I hope. All of your written response questions have always said this. Your responses must be complete and clear. You need to show all of your work. You need to state equations that you're using from your formula sheet. If you develop your own equation, you need to explain where that equation comes from. You need to show substitution with units, and then your final answer with units and the right number of significant digits. And finally, you need to explain any physics principles that you use. And stating and explaining physics principles does not mean something like, I used physics principle number 1 from the formula sheet. If you used uniform acceleration, then you need to say, I used the principle of uniform acceleration because there's a net force. I'm expecting you to elevate your response to a grade 12 level in physics. Now, if we look specifically at the situation that you're dealing with in this question, you're not given any of the distances, but you will notice that at the bottom of this context box, it says the diagram is a one-to-one scale representation of the apparatus, and you will need to make measurements to answer this question. What does that mean? It means you're going to actually have to take a ruler. Now, I don't have a ruler handy, but you're going to take a ruler. You're going to print this out, first of all. Then you're going to take a ruler. No, so I don't have a ruler here, but I'll just draw one. You're going to take a ruler, and if for some reason, and I don't know that you're going to need to do this, but if for some reason you need to know the distance between the plates, then you need to take your ruler and measure the distance between the plates. So all of your distance measurements are going to come from this diagram and a ruler. I realize as I'm speaking that you might not have a ruler at home. That's a possibility. So I will see if I can make a PDF of a ruler that you can print out, and when you print it out, it will be the actual size of a ruler. So that assignment is due next Tuesday. You need to be responsible here. I know that all of you are, but tomorrow we're moving on and learning something new. And you're going to have some work for practice, some kind of homework dealing with tomorrow's lesson. Friday is a day of working, so you can go to Google Hangouts and ask questions. And Monday, we're moving on and doing something new as well. So you need to keep track of all this. You can't leave this assignment until the last minute because you may not have time to complete it. Anyway, it is due next Tuesday. I really do miss you guys. I would have much rathered us be back together. But it is what it is, so we're just going to have to power through this. Have a great rest of the day. You'll hear from me tomorrow. And remember that I expect you to check into Google Classroom every day. So have a great rest of the day, and I'll talk to you tomorrow.